This is Chycho, back again. There's a couple problems that I wanted to take care of, just finish off the exponents and radicals section that appear a lot in a lot of exams that I've seen from different types of schools and stuff like this. And basically it's a type of problems that they really like giving because it's, you know, they look difficult, but they're extremely simple. And it's just basically radicals within radicals. So for example, if you had square root of 2 plus the square root of 4. That's a typical type of problem they give. These are really simple, but for some reason, you know, having a square root symbol inside a square root symbol really throws people off. Now, the way this works is, I'm assuming you guys, or if you're dealing with this kind of stuff, you've already gone through your BEDMAS, you know, the principle, whatever it is, where you're talking about, you know, brackets, exponents go first, and then multiplication, division, addition, subtraction, right? So I'm assuming you know the order of operations. I'm assuming you know the order of operations. So the way this would work is, if you get something like this, where there's addition and subtraction inside a radical, you have to deal with the inside first. So what you would do here is, 4 is 2, 2. 2 2's come out as a 2. So this would be square root of 2 plus 2. 2 plus 2 is 4. So this becomes the square root of 4. Square root of 4 is just 2. So the answer is 2. Okay, really straightforward. Let's do a little bit more complicated one, okay? So let's say they gave you, you know, something larger. Let's say they gave you plus, what do we got? Square root of 4 plus the square root of 16 plus 2 squared. Okay? So what we got here is multiple, you know, root symbols within root symbols, and we've got a radical there and a exponent there, and radicals are just exponents, right? So the way you do this is you deal with each one separately, and then when you combine your like terms, and at the end you take the square root of the whole thing. So first thing you do is square root of 4. Let's rewrite this here. Okay. So the 8 we can't do anything yet, right? So we just write down the 8 as an 8. We got plus square root of 4. We should already know that. That's just 2. Over here, you got the square root of 16. Square root of 16, if you break it down, it goes 4 times 4. And you don't have to break down this. You don't have to break this down to its prime numbers, because you already found a pair, right? Square root means you're looking for pairs, clones, right? If this was a cube root, you'd be looking for triplets. But you already got a pair, so you don't have to break it down anymore, right? So as soon as you get a pair with the square root, circle it, you're done expanding that tree. So square root of 16 is 4, and square root of 4 is just 2. It's just the same thing here. So that becomes plus 2. 2 squared is 4, right? So now what you got is, can we go down here? We can go down here. Square root of 8 plus 2 is 10, plus 2 is 12, plus 4 is 16. Square root of 16. And square root of 16, we already did it over there, is just 4. So this whole thing turns into 4. Now, keep in mind, you don't just have to have square root symbols, right? You could have cube root, the 4th root, or something like that. So let's just do one more where it's just not a square root, it's a cube root or something like that, okay? Okay, so I just made up another larger problem with cube, you know, the cube root, the 4th root, or something like this. So let's say you had something like this. You had the cube root of the 4th root of 16 plus, what do we got? The square root, cube root of 8 squared plus the 5th root of 32 all squared. Okay, does that come out okay? Well, hopefully you can see that. So this is the cube root of the 4th root of 16 plus blah, 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 blah. You got the whole thing here, right? Now these guys are separated by additions, right? So each one you're going to have to deal with separately, because you can't combine anything right now. Everything's all, you know, to the different roots and different powers. So what you got to do is do each one separately and then combine at the end and see if you can take the cube root of it. So what we got here is, you write down your cube root symbol here. The fourth root is 16. This breaks down to 4 times 4. 4 is 2, 2, 2, 2. So you're looking for the fourth root. You got 4 2's right there, right? So the fourth root of 16 is just 2 plus. You got the cube root of 8. 8 is just 2, 2, 2. So that's the cube root. So that's going to be, cube root of 8 is going to be 2. 2 squared is going to be 4. And the square root of 4 is just going to be 2 plus. You got the fifth root of 32. The fifth root of 32, this breaks down into 4 times 8. 4 is just 2, 2. 8 is 2, 2, 2. So fifth root of 32 is just 2. 2 squared is going to be 4. So that's going to be 4. So what you got now is the cube root of, we're low enough? Yeah. The cube root of, I shouldn't go so far anyway, because that's just going to break down to the last term, right? So it's going to be 2 plus 2 is 4, plus 2 is 8. So it's going to be the cube root of 8, which is, well, we should know by now what the cube root of 8 is, okay? So cube root of 8 breaks down to 2 times 2 times 2. So cube root of 8 is just going to be 2 again, okay? So these are just a set of, just a branch of questions that they really like, most teachers like to give in exams, because, you know, they test the basic operations, the basic radicals and the basic exponents, where you're taking it, squaring it, cubing it, or whatever you're doing it, okay? Yeah, so deal with these. They're not very difficult. They look ugly to begin with. Actually, they don't look that ugly. I actually like the way they look. So they just, you know, they tend to throw people off because people want to just, you know, go from the problem, go from the question all the way to the answer in one step. And you can't do that. You have to crunch things down until you can get them into like terms, and then you can deal with it, okay? Again, this is just simple radicals. You should be able to do it in grade 9. Yeah, definitely in grade 9. Most definitely in grade 10. And this is the type of stuff that you end up getting in grade 11 and 12. You know, when you start dealing with logs and stuff like that, okay? So that's just one branch of questions you get when it comes to radicals.